Hi everyone, my name is Chirag Subramanian, and today I'm going to speak about navigating the roadmap to becoming a data scientist. I'm a data science professional with 8 years of experience in data science and analytics, applied to 4 different industries in the United States. Here is the agenda. I will start with an introduction about myself, my career journey so far. I will then dive into data science career, different aspects of a data science career, data science introduction. Why do companies hire data scientists? Machine learning introduction. Different types of machine learning and their use cases. 5 common types of data analytics jobs and skills required for each type of job. Data science career learning paths. Data science career progression at large companies and industry. Free online data science learning resources. Resume, networking, and job search strategies for aspiring data scientists. And finally, I will end with the decision tree classifier explained to a layman. And then we will have the offline data science career Q&A, in which you can be free to leave your comments and ask questions to me by DMing me on LinkedIn or reaching out. So I'll dive into the introduction, a bit about myself. I hold a Bachelor of Engineering in Mechanical Engineering from Manipal Institute of Technology, India. I then went to the US to pursue my Master of Science degree in Operations Research with a focus on statistics and data mining from Northeastern University in Boston. I graduated with my master's degree in 2016. I started my second Master of Science degree in analytics with a specialization in computational data analytics from Georgia Institute of Technology, Atlanta, USA, which is ranked 9th in the world by QS World Rankings for data science. And I'm 70% completed with my master's degree, and I plan to graduate in May 2025. I have 8 years of full-time work experience in data science and analytics applied to 4 different industries in USA. My core skills are data science and analytics, statistics, machine learning, deep learning, reinforcement learning, A/B testing, hypothesis testing, recommendation systems, propensity modeling, operations research, and all of the common technologies used in data science. I also bring to the table skills in cross-functional collaboration, teamwork, communication, leadership, and mentorship. So after graduating with my Master of Science degree in Operations Research from Northeastern University in Boston, I worked for 5 years at Aon, almost 5 years at Aon from 2016 to 2021, where my work revolved around statistics, probabilistic modeling, and machine learning applied to projects in the catastrophe modeling industry. Some key projects I worked on were the US Severe Convective Storm Catastrophe Model, K-nearest neighbors for hurricane track and central pressure simulation, and the US Florida Commission project. I then moved to Amvin's group as a data scientist, where I worked on a PCA-based XGBoost multi-class classification model to automate the classification of different types of insurance claims. Then I worked as a senior marketing analytics analyst at Holland America Line, and there I used statistics, machine learning, and data visualization applied to the travel and tourism industry. Some key projects I worked on in Holland America Line included K-means based clustering model for optimal customer segmentation, PI dashboarding, and automation of manual reports. I then moved to Walgreens Boots Alliance, a Fortune 16 healthcare company with an annual revenue of 140 billion US dollars for 2 years, from 2022 to 2014, where I worked on statistics, probability, machine learning, data wrangling, and propensity modeling applied to the healthcare industry. A project at Walgreens I worked on, which I'm proud of, is a credit card propensity tool prediction framework using an XGBoost multi-class classification model for Walgreens. And I scored 132 million customers with that model and deployed it in Azure. My deployed model led to a 35% increase in Walgreens credit card transactions. My next gig is as an incoming staff engineer, data scientist at Micron Technology, which is a global leader in the semiconductor manufacturing industry with an annual revenue of 16 billion US dollars in May 2024. I will be working as a staff engineer data scientist within the technology and product development group of Micron in Hyderabad, India. I will now dive into the data science career part. What is data science? Let's first talk about that. Data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data. Data science applies techniques from mathematics, statistics, computer science, and information science to analyze, model, and interpret complex data, aiming to make informed decisions and predictions. For example, while at Walgreens, I built a framework to analyze customer behavior and measure the impact of changes in customer behavior on on Walgreens' incremental annual revenue. That is an example of a data science project. Why do companies hire data scientists? Why are data scientists in demand? Companies hire data scientists for a variety of reasons. The plus points about data scientists are that they bring a unique blend of skills in statistics, machine learning, and computational tools, enabling them to analyze complex data sets, identify patterns, and predict trends. Here's how data scientists can add value to a company's incremental revenue through improved decision making. By using predictive analytics and data modeling to provide actionable insights, data scientists can enable companies to make more informed decisions. By understanding market trends, customer behavior, and operational efficiencies, businesses can then optimize their strategies and operations, leading to improved financial performance. Then, number two is through enhanced customer experiences. By analyzing customer data, data scientists can help companies understand their customers' needs better, and therefore companies can develop personalized products and services, which can help increase customer satisfaction in the long run. Operational efficiency. Data scientists apply their skills to streamline operations, reducing costs and improving productivity. By analyzing processes and workflows, data scientists can identify bottlenecks and inefficiencies, propose solutions, and automate tasks. These improvements not only reduce operational costs for the company, but also help companies scale their operations more effectively. Number four, new product and service development through innovation. Data scientists can drive innovation by identifying new market opportunities and trends. By analyzing data from various sources, data scientists can uncover unmet customer needs or emerging trends, guiding the development of new products or services that meet these needs, thereby generating new revenue streams for the company. Number five is risk management. Data scientists can build predictive models and risk analysis, which can help companies anticipate potential issues and mitigate risks. In sectors like finance and insurance, this capability of data scientists can lead to more accurate pricing, better risk assessment, and fraud detection, therefore significantly impacting profitability. Number six is targeted marketing and sales strategies. Data scientists use customer segmentation and predictive analytics to design targeted marketing and sales campaigns. By focusing efforts on the most promising prospects and customers, companies can achieve higher conversion rates, increase upsell and cross-sell opportunities, and ultimately boost revenue for the company. And last is competitive advantage. In a data-driven world, companies that can quickly interpret and act on data insights can outperform their competitors. Data scientists enable companies to be more agile and innovative, responding rapidly to market changes and customer demands. What is machine learning? Let's now dive in deep into machine learning. What is machine learning? Machine learning is a subset of artificial intelligence that intersects with data science that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Machine learning focuses on the development of computer programs that can access data and use it to learn for themselves, identifying patterns in data and making decisions with minimal human intervention, making predictions with human-like accuracy with minimal human effort. For example, building a machine learning model to automate the classification of different types of insurance claims. Now, what are the different types of machine learning? Machine learning has four specific types: supervised machine learning, unsupervised machine learning, semi-supervised machine learning, and reinforcement learning. I will dive into each of these types briefly now. Supervised learning. Supervised learning is a type of machine learning where the model is trained on a labeled data set. This means that for each data point in the training set, the desired output or label is known. The model then learns to predict the output from the input data during the training process. Supervised learning has two basic types: classification, classifying input data into different target categories for data with categorical outcome. For example, identifying spam emails, recognizing handwritten digits, facial recognition, etc. And number two is regression, predicts a continuous or quantitative outcome based on the input variables. For example, predicting house prices based on features like location, size, and condition. Unsupervised learning. Unsupervised learning involves training a model on data without labels. The goal is for the model to find patterns and relationships in the data on its own. Unsupervised learning has three types: clustering, customer segmentation, grouping similar news articles, organizing computer clusters; association, market basket analysis, example customers who bought X also bought Y, and recommendation systems; and dimensionality reduction, data compression, feature extraction, reducing noise from data. Now, what is semi-supervised learning? Semi-supervised learning sits between supervised learning and unsupervised learning. It uses a small amount of labeled data along with a large amount of unlabeled data for training. This approach leverages the small amount of labeled data to guide the learning process within the larger unlabeled data set. There are three different types of semi-supervised learning. First is image recognition, labeling images when only a few examples have labels. Then the second one is language translation. And the third one is speech analysis. It's used to classify speech when there is limited labeled audio data. The fourth type of machine learning is reinforcement learning. Reinforcement learning is a type of machine learning where an agent learns to make decisions by taking actions in an environment to achieve some goal. The agent receives rewards or penalties for the actions it takes, and it uses this feedback to learn over time. Some use cases in reinforcement learning are game playing, AI that learns to play and excel at games like chess, Go, or video games; robotics, robots that learn to perform tasks like walking or picking up objects; and three is personalized recommendations, systems that adapt to user preferences over time, like streaming services adjusting content recommendations, for example, Netflix or Amazon Prime Video. Here are five common types of data analytics jobs and skills required for each type of job. Data analyst. The data analyst is an entry-level job requiring only a bachelor's degree. Data analysts analyze and summarize data, build reports and dashboards. This job requires proficiency in SQL, Excel, Python, basic statistics, and data visualization tools like Tableau or Power BI. Then the second one is data scientist. A data scientist is more commonly a mid-senior level job with a bachelor's degree and 2 years of work experience. Data scientists pre-process, analyze, summarize, and visualize structured and unstructured data, build machine learning models, and recommend optimal decision making for companies. A data scientist role requires proficiency in statistics, probability, linear algebra, machine learning, strong programming, and data visualization skills in R, Python, SQL, Power BI or Tableau, PySpark, Microsoft Azure or AWS or Google Cloud Platform. Sometimes deep learning and reinforcement learning frameworks like TensorFlow and PyTorch. And for some roles, there's also need of knowledge of algorithms and data structures. What is crucial for data science roles is business understanding and knowledge, skills in cross-functional collaboration, effective communication, teamwork, business stakeholder management. This is more commonly a mid-senior level role. The third type of job is machine learning engineer. Machine learning engineers build, deploy, store, and maintain ML models. This role needs strong programming skills, knowledge of machine learning algorithms, and understanding of data structures and algorithms. This is more commonly a mid-senior level job and requires a bachelor's degree plus 2 years of work experience. Data engineer. Data engineers build efficient data pipelines, collect, store, and ingest data, process and move raw data into databases. For this role, you need to focus on big data technologies, ETL tools, databases, and scripting languages. This can be both entry level as well as a mid-senior level role and requires at least a bachelor's degree. The fifth role is a business intelligence analyst role. Business intelligence analysts build data models, dashboards, reports, maintain data warehouses, communicate with business stakeholders. This role needs skills in BI tools, data warehousing, and data modeling, along with a strong business acumen. It's a common entry-level job with a bachelor's degree being a minimum requirement. So here are three common learning paths for aspiring data scientists. The first is the analytical tools learning path for statistical data scientists. This path focuses on the quantitative methodology, how to select, build, solve, and analyze models using methodology, regression, forecasting, data mining, machine learning, optimization, stochastics, and simulation. In this path, you focus on learning statistical software like R, SAS, advanced statistics, predictive modeling, operations research, and data visualization tools. The second path is the business analytics learning path for business focused data scientists. This path explores the understanding of framing, framing, and solution of problems for a business related context in various industries. For this path, you need to emphasize on learning basic machine learning, A/B testing, hypothesis testing, design of experiments, SQL, Excel, and BI tools like Tableau or Power BI. You need to learn how to understand business operations and develop analytical problem solving skills. The third path is the most challenging, and it's called the computational data analytics learning path for big data, ML, and AI focused computer scientists. This path focuses on big data, how to acquire it, pre-process it, store it, manage, analyze, and visualize it. In this path, students dive deep into programming with Python, PySpark, Scala, data visualization, machine learning, deep learning, and reinforcement learning frameworks, scikit-learn, TensorFlow, and PyTorch, and also algorithms and data structures and computational theories. Now I will talk about the typical data scientist career progression in large companies and industry. You typically start at the entry level as an associate data scientist, and then you move to a data scientist after 2 years of experience. After 5 years of experience, you move to a senior data scientist role. Then you move to a staff data scientist. Then you move to a principal data scientist, requires 11 years of experience. Then you move to a manager data science, requires 13 years of experience typically after a bachelor's degree. Then you move to a senior manager data science after 2, 3 years from that role. And then you can move to a director data science role. Then you move to a senior director data science role. This role requires at least 20 years of work experience after a bachelor's degree. And then you reach the C levels, like a vice president or a SVP of a company. Here are some free online data science learning resources, and I would advise people to follow this below order of studies. I have given resources for database, SQL, Python, Tableau, Power BI, linear algebra, statistics and probability for data science, an introduction to statistical learning with R or Python, the elements of statistical learning for advanced machine learning, a free A/B testing course by Google, Stanford algorithm specialization, deep learning by Ian Goodfellow, and reinforcement learning and introduction PDF. Here's some resume building advice for entry level data scientists. I would say to start by focus on education and courses. Emphasize your data science education. Include relevant courses, projects, and technologies or tools you've used. Include projects in portfolios. Detail any personal, academic, or freelance projects relevant to data science. Provide links to your GitHub or portfolio website to showcase your work. Highlight relevant skills. List both technical skills as well as soft skills. Tailor these skills to match the job description you're applying to. Internships and part-time work. Any experience in internships, part-time jobs, or volunteer work where you've applied data analysis or handled projects can be incredibly valuable. Highlight your achievements and what you've learned. Some more resume building advice. Formatting bullet points in your resume. Make it action oriented, which means that start every bullet point with a strong action verb. For example, analyzed, developed, or implemented to clearly articulate your contributions. List quantifiable achievements. Use numbers always to measure the impact of your achievements. For example, optimize data processing pipeline, resulting in a 20% reduction in processing time. And number three is relevance. Tailor your bullet points to emphasize the skills and experiences most relevant to the job you're applying for. Here I will talk about tailoring your resume and to the job application, to the job description. Match the job description. Carefully read the job description and note the specific skills and experiences required. Tailor your resume to highlight how your background aligns with these requirements. Create a different resume for every different job you apply to. It's harder than the usual approach, but it will certainly help you stand out. Use ATS friendly keywords. Many companies use applicant tracking systems to filter resume. Use keywords from the job description throughout your resume. This includes technical skills, tools, and any specific methodologies mentioned. Customize your objective or summary section. Adjust your resume's objective or summary section to reflect the specific role that you're applying to, mentioning how your goals align with the company's mission. Resume length. If you have less than 2 years of data science work experience, your resume should not be more than 1 page long. The average recruiter spends 6 seconds on an entry level resume, so keep your resume short, concise, yet informative to grab their attention. General tips. Reminder, keep it concise. Limit your resume to 1 page, especially for entry level positions. Be concise and focus on your most compelling information. Proofread. Typos or grammatical errors can be a deal breaker. Proofread your resume several times and consider having someone else review it. Professional format. Use a clean, professional layout with clear headings and a readable font. Avoid excessive graphics or colors because they might not be ATS friendly. Also, do not include photos of yourself in the resume. As an entry level data scientist, your resume is a critical tool to get your foot in the door. By focusing on relevant education, projects, and skills, and by carefully tailoring your application for each job, you'll increase your chances of landing interviews and starting your career in data science. Check out this free website below, which uses AI to help you tailor your resume to different job descriptions. Networking advice for entry-level data scientists. Leverage LinkedIn and other professional platforms. Create a robust LinkedIn profile showcasing projects, skills, and educational background. Sign up for LinkedIn Premium membership. Regularly engage with content from your target companies and use LinkedIn's networking features to connect with recruiters and industry professionals. Personalize connection requests with a brief introduction and your interest in data science roles within their companies. Participate in data science hackathons and Kaggle competitions. These events are excellent opportunities to showcase your skills, solve real world problems, and get noticed by industry professionals and recruiters who often scout for talent at such events. Attend industry conferences and workshops. Make the most of data science and tech conferences, seminars, and workshops happening across India or in your specific country, many of which are often attended by recruiters looking for emerging talent. Engage in discussions, ask insightful questions during sessions, and utilize breaks and networking events to introduce yourself to company representatives, handing out your resume or business card when appropriate. Here are some common websites for entry-level data science job posting. This list is specific to India, but you can also explore websites which are active in your own country as well. You start with some websites. The top 10 websites for India, especially, are LinkedIn, Naukri.com, Indeed, Glassdoor, Monster, Analytics Vidya, Angel List, Internshala, CutShort, and HighRist. Angel List, CutShort, and HighRist are specifically for startups and tech companies. I will end with explaining how a decision tree classifier works, a simple explanation to a layman. Look at the image on the right. That is a regular tree that you see on the road, but only upside down. That's how a decision tree looks like. There are different branches which split off into even smaller branches. The split starts at a tree trunk or root node, and at each split, there's a branch on the right and a branch on the left. Every branch corresponds to a different decision that the model is making. This splitting is done in a greedy way, which ensures that the model always creates new branches, which will reduce the error made by the model on all data points, hence increasing model accuracy. This splitting continues until there are more than a minimum number of data points in each branch, which is higher than a set threshold. Now let's look at the image on the left. This is a simple decision tree which is making decisions. The splits on the left and the right are called decision tree rules. For example, at the top, it starts with, does the person have more than 3 family members? If yes, then it goes to the right side. Otherwise, it goes to the left side. Let's take the path on the right side. Is the person married? Assuming he is, then he's eligible for a 3 bedroom hall kitchen. If he's not married, then we ask the question, is his salary greater than 40,000 INR per month? If yes, then he's eligible for a 2 bedroom apartment. If not, then he's eligible only for a 1 bedroom apartment. Now we go back up to the number of family members box. Is the number of family members greater than 3? If no, we check whether his salary is greater than 80,000 INR or not. If his salary is greater than 80,000 INR, then he's eligible for a 4 bedroom apartment. If his salary is not greater than 80,000 INR a month, then we ask the question, is the person married or not? If the person is married, then he's eligible for a 3-bedroom apartment. And if the person is not married, then he's eligible for a 2-bedroom apartment. So this is a simple way that a decision tree works. I've explained the rules of a decision tree and how they make decisions. Now I will take questions from people who are data scientists and who are aspiring data scientists. You can post your questions on my post below, or you can DM me your questions as well.